57 in section 8.5, and we're asked to simplify this expression, the square root of 24 over x. Now that means we want to rationalize the denominator. Remember, you should never leave a final answer with a radical in the denominator. You always want to rationalize the denominator, which means get rid of any radicals. Now, if you don't have your radical rules next to you, get them out now. What we're going to do first is we're going to divide this into two radicals. So, square root of 24 over the square root of x. This is one of our radical rules. We're allowed to do it. And by doing this, we can look at each of these separately. So in the top, can I do anything? Yes. I can change this into 4 times 6. The reason I want to do that is because 4 is a perfect square. And I can take it. So that means the top is 2 radical 6, and the bottom still is the square root of x. Now we can't do anything with the square root of x, but we need to rationalize it. To rationalize the denominator, we're going to times by the same radical because they will cancel each other out. So, square root of x over the square root of x. Remember, we can multiply by anything that equals 1, so it's same top and bottom. This works for radicals, so just like you can times by 3 over 3, you can times by the square root of 3 over the square root of 3. And this is what we're going to use to rationalize the denominator. So these two bottoms are going to cancel each other out to just give us x. In the top, I have 2 times the square root of 6 times the square root of x. Now what I'm going to do here is this works reverse. Remember, our radical rules say we can take two terms like this and divide them into two parts. That's what we did here so that we could take the radical, the root of the one we knew, the square root of 4. We can do the same thing in reverse. So this is 2 times the square root of 6x over x. We cannot cancel these two x's out because the top one is under the radical. They are not the same term. You cannot cancel them. But we can leave it like this. We have a rational denominator. We can't do anything more that's under here. So this is our final answer.